Hello friends, आपको नमस्ते. So today in this video we will train faster RCN model on animal detection dataset on a custom dataset. So let's get started. So let me first download the install this overflow library. Now let me download my dataset from the overflow. Okay, it's taking time to wait for the seconds. Before that, I will you can say I will change the old name to the new name. Okay, like this. If os.path.exits means if the old name is exist and not this new name, then we will rename them. Otherwise, if it is exist, it means rename is case source not found or already removed, already renamed. So let me learn this cell. Okay, so this way our name has changed. You can see this, and let me show you YML file. How many number of classes which we have? We have four number of classes: buffalo, elephant, rhino, and zebra. Okay, these are the directories. So let me close it now. These are the libraries which we use torch for training, pytorch for the training. Okay, these are the libraries which is required. DataLoader to load the dataset into batches, transformation to add to convert the image into tensor. Okay, which is required for pre-processing or image processing. Okay, now we will create a custom dataset class. Why there is need of custom dataset class? Because it's created to load images and their corresponding annotation file, convert them into a tensor format, and then will return it. So that's because due to that purpose, we have to create this custom dataset class for PyTorch training purpose. So here it is init function where we have some parameters: self, image directories, annotations, annotation directories, and transformation. Initially it is none. Okay, then we will initialize those variables, and this here self is used to access those parameters inside the variables, sorry, not parameters, variables inside the class without passing them as a parameters in the functions. Okay, so it's we can easily access them. Now length will give me the number of annotation file, or you can say number of images present in for training. Get item, it basically active for with the id. Okay, so after getting the id, it will give me the annotation file name. After getting the file name, we have to get the image path. How we can get the image path? Just use os.path.join, then image directory means this one. Then the just last four digit, we do not require last four character. Sorry, it is not digit, last four character we do not require it, because last four character is .tx. Instead of that .tx, we require .jpg to make the image path. After getting it, we will read the image. Okay, if it is not there, if the image is not there, it will return this error. Okay, after that, we are reading the image by using a cb2, so we have to convert that image into the bgr, so into rgb. So that's why we required cb2.cbt color, then pass the image, then we convert that into bgr to rgb. After that, we get a dimension. Why there is a need to dimension, I will explain you later in the code. Okay, after that, we have to open the annotation file to get the bounding box coordinates values. Okay, because the model, the data set is in the format of, we can say it is in a format of YOLO v8. So we have an YOLO format. Data set is have a x center, y center, width and height. The bounding box details is like this. So now we have to get those values into bounding box coordinates value, like x mean, y mean, x means, y means. How we can do that? So let me first create the boxes and labels empty list. After that, we will open the annotation file in the read mode. Then all thing will be saved in this f variable. After that, we will loop over the f variable line by line. Okay, now we will read line by line. So after that, we will split line dot strip dot split. Suppose it give me this type of index, like after using this line, it give me this way list, like this way. First thing, all thing will be in a character. Okay, so don't worry. So first thing will be the class id, like 0 is a class id. Then it will give me the x center. X center may be 2. I am just assuming that all those values in a normalized format, so it will be in a float format. 0.2, like this. It will give me x center, then y center 0.3, let's assume. Then it will give me width and height. Like this, it give me the list of whole thing in a string format. Okay, now how we can get a class index? Say this. I just first get the class index and zero index value. Then I will just convert that into a string into the int. So that's why this way I will get a class index. Now how we can get a class center, x center, sorry, x center. First we will use data dot I data then one. This way I get a you can say x center. After that, getting the x center, we will convert that into the float, because if I will convert directly into the int, it will just give me the zero value. Okay, so for getting the float value, then we will multiply it with the width. Why we will multiplying with the width? Because this value, these values, when I will use this strip the split, okay, these values are in a normalized format. So, but we have to come back those expand those values into the pixel value related to reference to the pixel value. So how we can do that? Just multiply with the width, we will get a values. No, okay, then how we can get a bike center? Data 2, then multiply with the height. Box width will give me the data 3, then multiply with the height. After that, how we can retrieve this x center, x mean, y mean, x mean and y mean. This two is a top left corner coordinates of the bounding box. X max, y max are the bottom right corner coordinates of the bounding box. So how we can do that? Getting this, when you will multiply box width divided by 2 and multiply by x center minus 1 minus box width divided by 2, it will give me the x mean. And same way, y mean and x mean and y max is calculated. If you're getting any calculation that how this calculation are going on, so you have to take one example and manually on a paper you have to do some calculation. Then only you will understand that how this calculation is going on. Then only you will get a clear idea that what is going on here. Okay, after getting this x min, y min, and x min coordinates value, I will append those in a boxes list and a label list. After that, since we are using a PyTorch and everything has to be in a tensor format, so I have just convert those boxes and labels into tensor, and this whole thing is happening for the single image. Okay, this idx basically give me the we can see give me this information for the single image only. Okay, all information is stored here for the single image. If any transformation is there, we will apply those transformation to the image transformation is like adding some data augmentation, or you can say changing the image into tensor. This all things is happening in the transformation. Okay, transform. Then we will create one dictionary target, which name is target. Boxes give me the boxes information, labels give me the labels for the particular box. Then it will return the image and a target. So this is the use of the custom data class. Now, number of classes, see 91 are actually object classes. This is not required. Okay, this is like it will be 4. See, total number of classes that model should predict. One class is always required for background. But you already know that every means the data set which we using Coco V1, the data set which we are using is zero index value is always fixed for the background. So we will see. I have done also one thing where it is going. See here, label. In label, I have adding one class index plus one, because zero index value is always fixed for the background. So there is not, if we do directly class index and does not use plus one here, so there will be confusion in labeling, and it will not give me the correct result during testing time. Okay, because of that purpose, use class index plus one, and total number of classes is now become 5 including the background. Now we will load the pre-trained model. The model which we are using is torch vision.model.detection faster RCN resonate 50 fpn. We are using this model for the training purpose. Okay, now we are using the Coco dataset. Okay, now we have to see. Now let me run it. This model is currently is not in a condition. Torch vision is not defined. Let me. Okay, there is one another problem in this. Where it is going, FPN, faster RCN and resonate 50. Wait, torch vision model detection. I think so. I have not run that. Oh, I have not run this cell. Sorry. So it's running. After that, this will run. Okay, done. See, this model before any changes is look like this: ROI head, box head, and a box prediction means classification. So see, what the out feature is 91 because right now we are using Coco dataset. So Coco dataset has 91 classes. Out feature 364. When you multiply, and for the box prediction we have four coordinates values. So when you multiply 91 with 4, you will get 4 into 4 and 4 9 36. So 364 value will becomes. So this way it's two things is not required to our number of classes. It's not worth for our number of classes. We have only 5 classes, so we have to change this part. So how we can do that? Okay. See how we can do that. First, we have to require the in feature. Why requiring the in feature? See, in feature is important because it's a check how many output, how many in channels, how many we can say how many in channels we have to connect with the backbone. Okay. So to connect with the backbone, we require the out channel of the backbone, which act as an in feature for the current layer. So how we can do that? For that, we have to use this in feature. How to retrieve this in feature? Model.roi head, then box predictor, then class score, then in feature. See, ROI head, inside the ROI head, box predictor, inside the box predictor, class score, inside the class score, in feature. So this way we retrieve the in feature. After retrieving the in feature, now we have to see, replace the existing classification head with a new one. See, replacing the ROI head with box predictor with torch vision dot model dot detection faster RCN. This way we replace it with our number with according to our number of classes. We first give the in feature and number of classes according to the number of classes which we have. So this way we get it. Now let me run this print this model again. Now this model is according to our number of classes. See, out feature is 5, and you multiply 5 into 4, you will get 20. And why we are multiplying with 4? Because box prediction have four outputs, so that's why we multiply with 4 with 5 into 4, you will get 20. Now now we have to create a objects, or you can say data loader. How we can do that? First thing is train image directory, train annotation directory, train annotation or list directory, then train annotation directory. Okay. Then we require transformation. Here we are applying the transformation is converting everything into two tensor. Now train dataset, custom datasets. Okay. Now this way we create a object of our class. We passing the train image directory, train annotation directory, and transformation. Now data loader. Why are we using a data loader? Create a data loader that load training data into batches of 4, shuffle the data each epoch, and use a custom collect function. This function, custom collect function, why are we using it? To group images and targets separately, useful when the different sizes used in object detection. That's why it's require collect function. Shuffle will be true. Batch will be right now it will true, means e in a single batch 2 images will be there. But okay, and it is a object which we are passing. So this way we create a data loader. Okay. Now how many number of batches we have? 587 batches we have. And when you multiply 587 into 2, you will get 1174. This much number of images which we have. Okay. And this is setting a GPU. Okay. Why we require a device? Because it is important that all things, that images and targets and labels and model always has to be on the same device. Otherwise during training it will throw error, or during testing it will throw error. So that's why we know that everything which is happening on which device. It is happening on a GPU or a CPU. So how we can get it? So we use if torch.coda is available, it means the value will be coda, otherwise it will be CPU. So this way we get it. Now the model parameters and buffers to the selected device. So we will buffer to the selected device. Now we want to know that how many number of which parameters is trainable during training. So how we can do that? How we can know that? For that purpose, how we can create this list? So for that purpose we use this thing. If p in modeled or parameters, and if parameter dot required grade is true, it means it is trainable during training, so that parameter will be saved. Then in optimizer is basically important part which update the weights. during training. So the optimizer which we are using as SGD, we are passing the parameter which is trainable. In the learning rate which we are using is 0001, momentum is 0.9. Now number of epochs is initially stand, but right now I just use two, or you can say one epoch is right now is enough just for the explanation purpose, because I already have a weight file which is trained on 10 epoch. I will show the result of that model. Okay. Now this thing, sometimes it is sometimes we cannot sometimes number of classes in data.yml file is very high. Suppose it is 20 or 21 classes, and we cannot not manually type the class name. So how we can retrieve class name easily, or we can easily get a class name list. So what that is, just use see here a class name, then passing the animal data.yml file. It will open a data.yml file in read mode. Everything will be safe in F, and yml.saveload f, everything will be saved in data, and just give this directory, or in the key value data.name, give me all everything in a list format, return, and everything will be stored in class names. And when you print the class name, you will get buffalo, elephant, rhino, and zebra. So this way we retrieve the class name list. Now let me run it. Now we have to check the DataLoader that the class which we have created is correctly giving the labels and bounding box on a correct image or not. So how we can do that? First we have to create the iterator. So this way we create the iterator here. Okay, train the DataLoader. After creating the iterator, we will just use the next. It will give me the images and targets to me. We just want to plot two images, so we use plot.subplots. One row, two column means two images. Figure size will be 12 by 16. Then figure is basically representing the entire subplot. X is just for the iteration over the subplots. Here X is in a 2D format in this line, but when you will extract variable, it presents to 1D format just for the iteration purpose. We are plotting the two images, so we use for loop two times. Now here we using, see one more thing, when you will use this transformation to tensor, transmitted to two tensor to on images, then the dimension of the images from HWC convert to CHW. Okay, but for the plotation purpose we require the HWC format. So how we can do that? Just use image ideas that permute 1 to 0. Your dimension is gets changed. But for the plotation we have to move this. Everything has to be on a same means it is not on a GPU. So what we have to move this image to the GPU. So that's why you moving it to the GPU. Sorry, CPU. Other and to plot rectangle and put text in images, we have to see till here the image is in a tensor format till here, but we have to make sure that for plotation, for putting text or rectangle on our images, we have to convert that image into numpy. So that's why we use numpy here. After we make a copy of it, why we are making copy of it? Because the values are in a normalized way. Okay, so because we are using two tensors, so all values in a normalized. Let me print the image so that you will get a better idea. Okay. Okay, let me print image, and then you have to break it. Let me run it now. Wait for the seconds. See, values are in not in a correct way. It's in a normalized way, normalized form values. So that's why we are multiplying with 255 to make it in a 0.255 0 to 255 range. Okay, then making copy of it. Then we have to make means we have to get a particular image boxes information and level information. Same thing that CP and NumPy is used is the same reason that why we are using CP and NumPy. After that we will over the loop over boxes and label at same time using a zip. Okay, and why we are using a zip here? Because each bounding box has its own label, so that's why. And this line give me the color information, not color information, color. It will generate a color, random color of three values. The next time we will see means we map all values x min, y min, x min, y max value to these variables. After that we just plot the rectangle, sorry, not circle, rectangle. Just pass the image x min, y min, x min, y max value, then a color, then the thickness. Then how what now we have to put the text. For putting the text, we use image. Then a class name will be label minus one. Why we requiring label minus one? Zero is for the background, but you can see the list zero value is for the value. So that's why we multiply minusing b minus one here. Then this is x min max my min minus 10 20, because so that so that the text does not go beyond the image, outside the image. And this is a font, this is, you can say, scale, this is a color, this is a thickness. And let me now run this. This is just here we are plotting the image, then type layout, and then we'll just plot the everything. Now I have make sure that yes, everything is okay now. Now let me run it now. See, everything is perfect. Now let me show you how we can do training part. So for visiting this bar here, this white bar, how we can do that? Just using for the purpose, we use TQDM. Training loss basically give me the means store the loss for each epoch. Now according to number of epoch, we loop over the for loop. After that, it will print starting training of epoch. For each epoch, it will print this line. Now here the model has to in a train mode, means every weight file has the weight file which is trainable is those value will be changed during training. Then for each epoch, training running loss will be initially it will be zero. Now here we applying the TQDM. These are the parameters, or you can say attributes. Here the train data loader, then the length of the train data loader, then the line which we want to display, and this is will be true. Then p bar, we will loop over the p bar, we will get the images and target. After see above, I have explained you that why we are putting images and target in a same device. So this way we are doing it. Okay. Now after that, we will pass this image and target to our model. It give me the list of all the losses in a dictionary format. Then we iterate over the list of loss sticks. Here we iterating over the loss stick values, and we are summing those values. We making a sum of all losses in a single variable, losses variable in the single variable, this one. Now this is a weight to how the weight is updated. This is you can say the formula of that. This is the old weight minus the learning rate into the gradient. And what is the use of this gradient? Gradient basically tell that in which direction weight should change to reduce the loss. Now here, see, optimizer zero grade. What is the use of this? Clearing previous stored gradient. You can see in the formula that if we do not make this gradient value initially zero, then the previous gradient value will accumulate to the current epoch gradient value, and it will disturb the training. So that's purpose. We will first make the gradient value zero. Now here losses dot background basically calculate the gradient value for all weights. Then optimizer optimizer dot step basically what is happening here. See, here the calculation is performing, here the updation of the weight is performing in this line. Okay, here the updation is performing, here the calculation is performing. Now here accumulate batch loss. Here it's all losses will be accumulated to the batch loss. Then every batch loss is, you can say, in a store in training running loss. See here this loss is just for the one batch. Okay, is a losses for the one batch, and every batch loss is you can say adding to the training running loss value variable. After whole whole batches is completed, or you can say first epoch training is completed, we want to calculate the epoch loss. How we can calculate the epoch loss? Training learning loss, which we have created for each each batch, not epoch, each batch we have calculated, and we'll divide by length train data loader. It give me the each epoch loss. Then we will just append it to the train loss, which store the each epoch loss value, then will be printed. Okay, so this way it's all happening here. Now this is a graph. I will not run this cell because we have just trained the model on the one epoch, but this is a loss for the 10 epoch. This is a graph for the 10 epoch. How we can doing it? Just we have to first create epoch log. Then we use figure.ax1.plot the subplots. Same way. ax1.plot epoch loss, x value, y value. Yes, r1. This one label will be train loss. Set x label, y label. Color will be red. Set title, legend, show. So this will be flotation. I will not run this cell. Now here we how we can save the model. So first we have to create the path. Now how to save the model, we use torch.save model.stateDict then path. Just skip the path. Your model will be saved. Now we have to plot the images, or you can say we have to test the model. How we can do test the model? So for that purpose, everything is remain the same. First you have to give the device. How you can calculate what is the device, number of classes, and same thing is happening here. We have to create the model. Okay, we have to create the model from scratch. I've explained each and everything here. Okay, and then after that we have to load the model. See here we have load the model, pre-trained model. Okay, now here we load the weight files. Okay, so how we can do load the weight file? Model dot load dot state dict torch dot load, then the path of the model, and map location will be CPU. So this way we load the weight file, model to device, and here the model has to be in evaluation mode because here we are testing the model. After that, true tensor is required because during testing training time we have to we apply some transformation. Same thing has to be applied here. So true tensor is has to be applied here. Okay. Now this is a text directory. This is first we create the list of all the number of list of all the name of images present at particular test directory. Then we have to plot subplots, 4 rows, and we have to plot 16 images. So 4 rows, 4 columns. Now figure size will be 2020. Then figure and axis. Then we have to use ax is equal to ax dot table. But I have explained you everything is same here. What is different is image path. How we can get an image path? Where's path join test directory? This is a test directory. Now it will randomly select the image file name from the list which we have created. After that, we will open that image. This is not required. Convert RGB is not required because already we have read the image in RGB, so it's not required here. Now image transformation tool, we apply some apply transformation on the image because before passing that image to the model directly. Now see during training we pass the image, two image at a time to the model, means we adding a batch dimension to it. We have so same here during testing time we have to add one batch dimension to the image. So how we can do that? We have to, for that purpose we use image dot unsqueeze 0 to device, means same here we add one dimension. Now then we have to pass that image on device. Okay, now torch dot no grade means there will be no updation, no updation will be performed. Then directly pass the image tensor, and 0 is just to get we are just passing a single image. To get the single image result we use 0 index value. And now here just everything is remain same, that we have to why we are using image dot mp, means image dot permute 120.cpu dot numpy, and this thing same thing I have during checking a data loader I have explained that why you are using this two line. Okay, now this way we get labels and score and boxes from the model predictions. How we can do that? Prediction boxes dot cpu dot numpy, prediction labels, prediction score, they will give me the everything. And see each boxes has its own label and its own score value, so that's why we use zip for on all three variables. If a score value is 0.8 means the threshold if needed. Threshold means if the score is 0.8 then only we plot the bounding box around the images and show the text around over it. This give me the color. This line give me the color. Okay, this is a rectangle here. Okay, and this is a text. See we are giving the class name label -1. I have explained that why we are using label -1, and score is this way we are displaying the score here. And why we using myWin and -10 20, it's because the text does not go beyond the image, outside the image. Now this will show the image. Now let me see that training is completed. See training is completed. Model is, I think so. I have not run this cell, so let me run this cell. Now let me show the plotation of the model which is trained on just one epoch. What's the problem? Oh, sorry. Model.pth is the path of the. Okay, now let me run it. I know some no plotation will be so because the model is trained on just one epoch. And I have applied one condition also here, that is, if the score is score is greater than 0.8 here, then only it will show the plotation. Oh, somehow it's working very well on buffalo. And see, two deduction is this is rhino and buffalo is misunderstanding. Rhino, perfect. Okay, it's working very well. Now let me. So there is no need to show you the result of the model by just training an epoch. If you increase the epoch value, then the model is perfect for detecting the animals, buffalo, rhino, and zebra. Okay, so if you from my video, if you gain any knowledge, anything you will gain from a video, so please like, share, and subscribe my channels. Thank you to all.